For Alexa David's first calculation problem, she addresses topics 1 and 3, which are the Bernoulli equation and the hydrostatics equation. And these are shown on a system that is air flowing through a tube that has water at the bottom of it. And you are supposed to find the volume flow rate at point 1. To do this, the assumptions that T1 equals T2 is made. There was constant flow, it was adiabatic, steady state, no friction, no work, that the fluid was incompressible, the air inside the manometer was negligible, and that the change of potential energy is 0. The properties that she used were the density of air and the density of water, which are found at tables A15E and A9E. To do this, she used the Bernoulli equation, the hydrostatics equation, the continuity equation, the equation for the volume flow, and the cross-sectional area of a circle. First, what she did was simplify the Bernoulli equation using the assumptions to find that the change in pressure was equal to the following expression. And then she manipulated the hydrostatics equation to find that P1 minus P2 equals rho of the water times the gravity times the height. Then these two expressions were set equal to each other to get this. After that, the V2 was found using the above equations in terms of V1 and other known variables, and then plugged back into this equation to have only one unknown variable, which is V1, which was solved for using solver. And after V1 was found, it was multiplied by the area to get the volume flow rate, which is 2,899.19 cubic feet per second. In her second problem, she addresses topics 2 and 4, which are Archimedes' law of buoyancy and momentum balances, by using a system that is, she was holding boba and it falls, and then you're supposed to calculate the weight of the displaced fluid of the boba after it falls, and then calculate the force of the lid holding the tea back. For part A, the assumptions that were made were that the forces acting on the boba are buoyancy force and the weight force, and that the density of the tea is equal to the density of water, as well as the boba is perfectly spherical. And the properties she used were the density of water, which is found at table A9. So known from Archimedes' law, the buoyancy force is equal to the weight of the displaced fluid, and the calculation for buoyancy force is density times volume times gravity. Using those two equations, she was able to find that the weight of the displaced fluid is 0.0409 newtons. For the second part, she made the assumptions that there was no friction, no work, that pressure acts in all directions and cancels out, that beta equals 1, that there's no other forces acting on the system, that the density of the tea is equal to the density of the water, that the boba is perfectly spherical, that it's steady state, that it's adiabatic, and that the flow rate is not in the x direction. The properties that she found were the density of water, which is from table A9. For this part, she used the typical in minus out plus generation equals accumulation equation to apply to an x-directed momentum balance. Then she used the equation for velocity in terms of area and volume flow rate, and the equation for the mass flow rate. After solving the x-directed momentum balance, she found that the force equals the sum of beta times mass flow times the velocity squared. Then she used the equations for velocity and mass flow to find the force in all known variables, and then found that that force equals 3.17 newtons.